Recently, a paper is published in Science which talks about the state and fate of Himalayan glaciers. This paper was a joint effort by international community where the scientists from different parts of globe, particularly from Switzerland, India, USA, Nepal and Canada and Japan, came together to review the existing knowledge of the Himalayan cryosphere. This particular work was necessitated because there was huge controversy about the Himalayan glaciers, and that controversy was started after the publication of IPCC report in 2007, which said that Himalayan glaciers are going to vanish by year 2035. In addition to that, many Indian glaciologists have also suggested that Himalayan glaciers are not at all retreating, and this has created huge controversy in the mind of people. Therefore, we have reviewed all existing knowledge in this field, and which tells about what is the present status of Himalayan glaciers. In addition to that, it also tells about how these glaciers are going to change in near future. In the Himalaya, glaciers are distributed throughout its mountain range. Large concentration of glaciers can be seen in a Karakoram mountain range. The huge glaciers are also concentrated along Great Himalayan mountain range and also in Pir Panjal mountain range. These are distributed in parts of Jammu and Kashmir. They are distributed in parts of Himachal Pradesh, Uttaranchal, in Nepal, in Sikkim, Bhutan and Arunachal Pradesh. And since they are distributed throughout the Himalaya, major Indian rivers such as Ganges, Indus and Brahmaputra originate from this glacier. In addition to that, numerous tributaries of these glaciers are also originated from these glaciers. And since these glaciers melt during summer time, significant amount of water is available into this river system during summer, and which makes this river perennial, essentially because water from other sources are not available during the summer time. This has helped to sustain Indian civilization for generations, and because of that, Indian people are aware about the importance and significance of Himalayan glaciers. And they also know that Himalayan glaciers as well as runoff from them can significantly affect the agriculture as well as power generation and also drinking water supply to the large part of the people living in hills as well as those living in the plains. Therefore, it is important for us to understand state and fate of the Himalayan glaciers. A recent work was carried out by International Center for Integrated Mountain Development at Kathmandu, and which suggests that total aerial extent of glaciers in Himalaya and Karakoram mountain range is approximately 40,000 square kilometers. In addition to the aerial extent, we also need to know how much is total water stored in these glaciers. In order to know the volume, we need the depth of glacier. Depth can be estimated by different techniques, and one of such technique is a radio echo sounding. But because of the typical nature of the Himalayan glaciers, we are not able to get good estimates of depth. Because of that, we need to apply different model to estimate the depth. These models based upon different principles. One of the principles is estimate depth by using slope. And if we apply that principle, the approximate depth and volume of glaciers is 2,300 cubic kilometer. If we apply the principle of volume versus area, then total volume of glaciers in Himalayas will be approximately 5,000 cubic kilometer. These estimates are substantially less than earlier estimates made by IPCC in 2007. And these estimates are important to understand us what is the present status of Himalayan glacier as well as how they are going to change in future. A significant work has been carried out to understand the rate of retreat of Himalayan glaciers. Normally, rate of retreat is estimated by mapping terminus of the glacier. Terminus is nothing but the end of glacier ice, and wherever glacier ice ends, such point or region is called as terminus. And this satellite picture, you can very clearly see the terminus of this Samudra-Tapu glacier. We have also plotted here the position of terminus in a different time. You can see the terminus which is in 1976, then it is 1989, then 2000 and 2006. By knowing the position of terminus at different time, we can estimate its rate of retreat. Normally, rate of retreat is measured along the center line which goes from the center of the glacier, and it is used to estimate the health of glacier. We have data for almost 100 glaciers, and all these glaciers are retreating. However, rate of retreat is varying from glacier to glacier, but bigger message is all glaciers are retreating. In addition to that, the sometime for 2 decades or so in 1920s, these glaciers were not retreating, some glaciers were stable, or even some glaciers were advancing. The recent investigation carried out in Karakoram mountain range also suggests that some glacier over there are either stable or they are advancing. However, the interpretation of the satellite images as well as interpretation of the rate of retreat to understand the state of glacier or the health of glacier is very difficult. You can see here very clearly that different glaciers are retreating at different rate. Some glaciers are retreating in very larger rate, like Parvati glacier, which is retreating almost 50 meters per year, and other glaciers such as Pindari, which is retreating in slower rate. And because of that, many people are saying that Himalayan glaciers might not have been affected because of the climate change. However, we have to understand why rate of retreat is different for different glacier. And one of the fundamental reasons it happens because many times glaciers carry lot of debris on it, and which is normally called as moraine, and the debris, because of the moving ice, moves towards the terminus of glacier, and significant amount of debris gets accumulated at the terminus. And if large amount of debris are covered on the terminus, the rate of melting at terminus will be significantly low, or it will reduce. However, the higher reaches of glacier, which will have no debris, continue to melt at the normal rate. And this creates anomaly on the glacier, where at lower reaches you have low melting and higher reaches you have a higher melting. Because of that, many tributary glaciers separate from the main body, and this change in glacial extent can never be understood if you are monitoring only snout. Therefore, it is important for us to understand overall changes in glaciers rather than merely measuring the rate of retreat at terminus. Another reason also, rate of retreat from terminus could be misleading because of the glacial dynamics. The modeling work is carried out at Divecha Center for Climate Change clearly demonstrates that why some glaciers are retreating and why some glaciers are not retreating. This particular case, we have studied the relative change in the glacier length of Gangotri glacier and Jhumu glacier. You can see here that Jhumu glacier is not at all retreating, and we have monitored from 1990 to 2010, and for this 20 years time, Jhumu glacier has not shown any sign of retreat. However, glacier height is reduced, but it is not reflected in the form of retreat. On the contrary, we already know that Gangotri glacier is retreating, and it is retreating at the rate of almost 15 meters per year. In the model, we have shown that both the glaciers are losing same mass, and even if the loss in mass is same, the rate of retreat is different for these two glaciers, essentially because the slope of the glacier. You can see that Zemu glacier for first 6 kilometers has very steep slope, and because of the steep slope, large amount of glacial ice is pushed into the lower reaches, and this is moving down the hill up to the terminus of glacier, and because of that it is not showing rate of retreat. However, Gangotri glacier has a much gentle slope. Because of that, the less amount of ice is transported into lower reaches, and therefore glacier is showing retreat from the terminus. The significant work by using satellite technology has been carried out in the entire Himalayan mountain range to understand how much glacial area is lost. We already know that Himalaya has approximately 40,000 square kilometer area of glaciers. Out of that, almost 20,000 square kilometer area is already mapped to estimate the loss in area, and the investigation has clearly demonstrated that Himalayan glaciers are losing almost 0.4% glacier area per year. Mass balance is normally estimated by measuring the amount of snowfall on the glacier and then amount of ablation or melting of snow and ice on the glacier. Accumulation of snow can take place mostly in winter, and in certain glacier it can also take place in summer, and the melting predominantly takes place in the summer time. If the amount of accumulation of snow and the amount of melting of snow and ice is equal, then glacier will have a zero mass balance, and the glacier will at the equilibrium state. If the amount of melting is higher, then glacier will have negative mass balance, and the amount of melting is less, then glacier will have a positive mass balance. Available data with us suggests that most of the Himalayan glaciers are having negative mass balance, and they are losing almost 60 centimeters of ice per year. This 60 centimeter of ice is over a unit area, and this is losing in the depth of glacier. Eventually this can be converted into the mass, total loss in mass. And this is a general figure, but that does not mean all glaciers are losing with the same mass. The recent investigation carried out in Karakoram region suggests that some glaciers are having a positive mass, and the investigation carried out in Indian Himalaya suggests that they are losing mass in much more higher length than other parts of Himalaya. This graph suggests that Himalayan glaciers are losing almost a meter of ice in this race, particularly in the Indian Himalayas, and the rate of retreat has significantly gone up from 1998 onward. Earlier decade, glaciers were losing almost 0.4 meter of ice, and as of now it is losing almost 0.9 meter of ice. And this significant increase has taken place in the middle of 19th century. In addition to that, many glaciers which are located in lower altitude could experience much higher loss in mass. You can see here, this is the glacier which is Parvati glacier, which is located into the Parvati basin in Himachal Pradesh, is losing mass at much more higher rate. This is essentially because almost entire glacier is located below the 5,400 meter, and you can see the present equilibrium line, which is around 5,300 meter. The equilibrium line normally means it is a snow line at the end of summer. What it really signifies is how much area is above the snow line at the end of summer, and that area will help in converting snow into the ice. So therefore, the health of glacier will depend upon how much area above the equilibrium line of the glacier. And you can see that for a Parvati glacier, there is hardly any area above the equilibrium line. And because of that, our model suggests that this glacier will be losing mass at the rate of 1.2 meter per year. This is much higher than what normally you see in higher reaches of Himalaya. How this glacier changes will happen in future will depends upon the different processes which are taking place in the mountain. We at Divecha Center Climate Change have undertaken program to understand and to monitor glacier changes in Himalaya, and we have come up with the two different processes which are likely to happen into the Himalaya and which has potential to change the rate of retreat quite significantly. One of our investigation has clearly shown that glacier could retreat much more faster than as of today if a significant amount of black carbon is transported from the plains and the lower reaches of mountain into the glaciated terrain. We can see in this picture that year 2009 large area was under forest fire, and these forest fires was particularly active in month of April and May. During the same time, large area on the plains have also experienced the agricultural fire, where agriculture waste was burning, and both the things have transported significant amount of black carbon into the accumulation area of glacier. And you can see this is very clearly on this investigation, and you can see that early part of April, that is 14th of April, glaciers has albedo as high as 95%. And as more amount of black carbon is transported into the accumulation area of glacier, you can see that this albedo has significantly changed up to the 70%. So this 23 to 25% drop in albedo is quite significant, and you also have to remember that this change in albedo in a spectral region between 0.52 to 0.59 micron, because this region is affected because of the contamination, and most possible contamination is the black carbon in this particular case. You can also say that from 18th May to 20th June, the reflectance was quite stable, and suddenly the reflectance have significantly changed on 25th June, and this has happened because at that time there is a sudden increase in the temperature, and as temperature increases, there is a melting process was also started in accumulation area. And remember, this area is very high altitude, which is at the 5,800 meter, and as there is a further reduction up to 45 to 50% in the reflectance of snow, and clearly suggesting that this is very large drop in the reflectance, and this can absorb incoming solar radiation in more efficient way, and it can significantly influence the albedo, significantly influence the mass balance of the glacier. Therefore, it is important for us to monitor how this black carbon is transported from plains and the lower reaches into the accumulation area ratio, because we all have to realize that change in snow albedo is an irreversible process unless there is a fresh snowfall into the region. And if this process gets accelerated or it happens every year, it has potential to change mass balance quite significantly. Another important process are taking place in mountain is because of the accumulation of debris on the glacier. We have already seen that as glaciers start losing the mass, its debris carrying capacity gets reduced, and because of that more and more debris are accumulated onto the glacier. As more and more debris are accumulated, the slope of glacier becomes gentle, and if it becomes gentle, then slowly small water bodies start forming on the glacier, and over a period of time these water bodies become large, and eventually this water body will merge to each other, and it forms a large moraine dam lakes. And if such stable moraine dam lake form on the glacier, it will transfer huge amount of latent energy from water to ice and start melting glacier in very fast rate. So these two processes have the potential to affect future change in the glacier. Therefore, we need a major program to monitor and model glacier into the Himalayas.